Hello, Zaid. How are you? I hope everything's all right. Uh, your study, your research, your everything that is going on with you. I hope really you're doing all right. I got a couple of things to tell you about. So I got better notes or better information about you know uh, what I talked to you about last time, not in person but in videos. Uh, so I'm gonna tell you about them now. So things worked out in my head. Basically, and you know what? There may be gibberish. There may be the foundation of what's going on. Again, this is continuing the commentary on that chimpanzee-looking Jew, your relative, right? No, he's not a chimpanzee. He's uh, he's a genius of a man. Give him that if you go by his grave, throw this on his grave, put this on his grave, a pen. Uh, so, uh, so it's conclusive now. A galaxy, really, all the way until the edge, from the core until the edge, is really the black hole. So a black hole is the galaxy itself, not just the core, right? Not just the core. And then it's like an onion, right? It's got layers. So as I mentioned, it's a reversal point, energy or that shade of spectrum of non-matter matter flows right in, right? And then in the center, it gets transformed, or let's say condensed, right? And transformed and condensed, right? Uh, uh, and uh, and then it begins to flow out, right, all the way through until the edge of the galaxy, and it keeps nourishing or taking its energy. Everything that flows out of the galaxy, the black hole, keeps absorbing energy from the black hole itself until on the edge of the galaxy, things flow out, and that's when they disintegrate completely. That's not when. I mean, they start disintegrating all the way through, but toward the end, that's when they basically just disappear back into that energy field. Uh, so the new information I've got today is really uh, is really everything that Albert was thinking about. E equals m, right? Or E goes to m and m goes to E. That's primordial, man. I mean, he was thinking the entire. I mean, he was thinking existence, no less, right? Uh, Now it's a little bit confusing. The equals is confusing because he used a constant or, as I mentioned, a variable, that delta x or whatever you want to use, right? Which I didn't know, neither did he, right? Uh, so we are, as Earth, we are in actually a black hole, right? But I come to discover, Zeno, or in my mind, that really everything in existence is really either that energy, non-matter matter, which I dubbed as non-matter matter, or a black hole. It's between the two, really, and the transformation in and out. Energy, mass, mass, energy. Well, we're probably talking, I don't know, billions of years or something of the sort, and velocity of light squared 2 and so on. But now, what I've discovered, Zedo, or struck me, and could be right or could be wrong, is that black holes is really the element of the other end of the energy, right? So when you go to M, the M side, not the E side, it's really an atom. So the galaxy or the black hole is really an atom, Zedo. So what is the closest atom or black hole to you, right? Everything here. Here I got, I don't know, trillions of black holes, all called atoms of different kind and different so on and so forth. There you go. But what's the difference? Am I saying that an atom can grow up to a black hole or as small as an atom or something of the sort? No, that's not what I have in mind. What I have in mind is the black hole, Zedo, uh, is composed of like unfathomable and imaginable number of atoms, right? All collected together, right? Or that's where they are born and transformed. So the core of the black hole is the maker of black holes, right? What you call as this big thing in the center of the galaxy or somewhere else. That's the manufacturer of black holes, right? Because the transformation cannot withstand like so much heat, so much mass, so much so and so. So it's a transformation, right? I mentioned earlier, it's a reversal point, E to M, M to E, right? But it's also a transformation, Zeido. It transforms that energy. It's a factory of transformation. And all combined together, all these nucleus and atoms and so on, and protons and electrons and so on, they form this huge mass called black hole, right? And then they're within, right? They are attached to each other, similar to them attaching to each other here, for example. And that's what I got. I think your uncle Albert had something to do, putting this here. So that's that. That's what he said. Now I got one thing. What is energy, right? I kept thinking about that, and I think I got on somewhere. I think, no, I really do believe that energy is heat, really, Zaido. The heat that we feel and cook with, and it's a byproduct of chemical reaction or electrical reaction, blah blah. That's what energy is. That's what the E in Albert's formula, E to M and M to E, right? That reciprocal formula, right? So it's really heat. Heat is fixed in this universe, right? Heat is fixed in this universe. And I said this to you, either one of your sisters before, or you, or I put it somewhere, that if there is a void or nothingness, which now I believe is heat, right? And then this is not as simple as that. I mean, out of this transformation, you will get like all kind of things, from water to gamma rays to huge reactions, to so and so, to so and so. So what I said to whoever it is that if there's nothingness in any place, then not even light will make it through. Right, Zedo? So that is, now I believe that is heat, and heat can expand so much. I myself tested it here. You know how I brew coffee and so on? And then when I have that coffee pot, the metallic coffee pot, and then I put it under, I cool it after I finish heating up or brewing or heating up my coffee, I put it under cold water because it's hot, and then I can clearly feel the heat move, transform, or transfers instantly from the body of the pot, right, to my hand, and it moves, right? So the heat is very fixed, right there. And then, I mean, I'm not the one who discovered this, and I think they call it entropy, right? But heat, that's what it is, they do. So, and heat can actually expand so much. It's like, consider this matter. I don't know the nature of heat, to be honest with you. I don't think it's electrons and atoms or anything of the sort. And that's what he called energy, and that's what I call non-matter matter, which is a shade of that spectrum, which we don't see and which we don't sense, right? So that's that. So black holes, uh, black holes, that's what it is. An atom is really a black hole, and there are, of course, higher degrees of black holes that, you may have like a plutonium black hole, you may have and hydrogen black hole and so on, but that's where heat condenses, right? And there's something else, of course, mentioning plutonium, radiation maybe, I don't know, maybe that's an excess of electrons and neutrons and whatnot, right? And that keeps like going through because it's so dense and so, and the mass of it is very high, it causes like destruction and cancer and so on and so forth. That's what I believe, that's what came to me, Zeido. So that's energy. So now two things would hit me. And one of them, you gave me a clue to when we met in the library. Do you remember that limit series that you showed me? And then I guessed that, you'll never reach the limit, right? which was 2.5 if I recall correctly. And sure enough, you agreed. uh, and like they say, stupid minds talk trash and like, since you're my son, Zedo. So I later on I found something in your series, not on paper, but here's what I thought. Like they said, and speaking gibberish, you know, خراي عليك يا خر. تلحس. That's how you talk, right? Well, خرا. Anyways, Zedo. So the series that you showed me, here's what I got from it, you know, what occurred to me from it, is really a slowing down, but never reaching the end, right? And that is opposite to Fibonacci. Fibonacci, it starts small, right? And then it expands and goes farther. So your series, Dedo, maybe the solution to that energy or heat or energy or non-matter moving into the center. You know, it slows down and compresses, slows down and compresses. So maybe that's the solution for how it works. I don't think this is a novelty, so I think you probably somebody else spoke of that, but not thinking that's how it is. And the Fibonacci, you know, going out, right? And then until it arrives not at a limit, rather at, say, nothingness, right? You know, equilibrium with energy. So that's what I'm thinking, Zedo. And basically that's it. That's what your monkey, chimpanzee Einstein, smart genius Einstein was thinking, you know, no less than existence. And that's what we see. That's the universe we see, Dedo. It's really between that energy field, energy, which is abundant in this universe. However, it's condensation. You know, and you know, inside the galaxy, which is a black hole, and then out. So everything is a black hole, including the sun, including the Earth. So now, Earth, right, or the sun absorbs energy from the center of the galaxy, right? Because there's heat, right? And maybe heat is really just within that entropy, or heat maybe just within the galaxy, right? Outside, maybe there's something else. I don't know. I mean, I'm just making these things up, but I believe they're real, right? And then the sun has also is not, although it's a black hole by itself, but it has many, you know, many smaller black holes in it, such as atoms, right? Now, I observed on the sun, and I told you that before I saw it, there are two opposing things, right? You know, and they're co-located. They're not like side to side, but they're co-located, right? That's always the case. They do duality of the black hole, duality of the atom. That's always there. They do. I don't know what it is, but I saw it. I remember looking directly at the sun, and then there was, you know, there was like, I could clearly see two things. One is larger than the other a little bit, or different color. So that's it, Zedo. So it's a step, right? It's a step. So the main galaxy and blah, blah, you know, the main black hole, smaller black holes, as it spins them out. What happens in the core of the galaxy is very simple, Zedo. I saw it on, and everybody did. I saw it on TV or somewhere. Not that I saw it myself. Is that sometimes there polarity forms, right? And that polarity is ejected into space. That polarity is very large polarity, Zedo, right? And that polarity really never materializes. It begins to materialize, right? Like a magnet, right? Like a magnet, you know, with small iron shavings, right? You know, and how the field begins to show and so on. You know, you can see that on the sun. Now, the sun is never able to eject that. But that, if it happens in the core of the galaxy, and that gets ejected and becomes the second class black hole, right? Which is a star, right? Which is a star. Now, here's what I noticed. In the sun itself is never able to eject those, and the black hole is spinning very fast. That's why, you know, things move out, right? Like a centrifuge. That said, Zedo, that uh, that said, people keep guessing about the Earth being used to be like part of the sun and so on, and no, Zedo. Here's what I discovered. I myself thought that Earth was at one point some kind of a moon for a certain planet or something, right? Uh, and maybe something happened, like maybe Saturn or Jupiter, maybe something happened, and then that smaller planet, which is Earth, got, you know, dislocated and was released and then was caught by the sun, right? Gravitational field. That's not how it works there. Everything. So the center of Earth is a black hole. The center of the sun is a black hole. It's a black hole, right? Every uh, 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 every planet is a black hole, Zedo. Every atom is a black hole. But then again, it's like it cascades down, right? In gravitational fields. So I can assure you, a planet like Saturn, Zedo, uh, would not have stayed circling or orbiting the sun for this long. No way. Or like Jupiter. It's not possible, Zedo. The sun is not that powerful to hold so much. So the sun, right? So there's something in there in the black hole that is really holding the sun itself as much as it's holding Saturn and Earth and so on, and Jupiter and Uranus, right? Uh, so everything that has a is caught by gravity or orbiting gravity, and it has its own core, that has at one point been generated by the black hole itself in the center of the galaxy. Stars, they just don't do that. So, but at one point, they get caught, right? When they're released by the center of the galaxy or the black hole, they get grouped into this like and you may not see it, you may see it or may not see it. So they release this gravitational field or framework, right? And which in the center of with the center there is this black hole, right? Smaller black hole, and then it's like ripples, right? Uh, that's probably a lot of bullshit, but hey, that's what it is. So I think your limit could be calculating inward movement of that matter or heat or energy according to Albert, right? And the Fibonacci could be calculated outward, right? Could be calculating outward. Now about that c squared, right? The velocity of light. Like I told you, I don't think he knew what it was, neither do I. Still don't. However, I found a clue that there is somewhere you can calculate this. So when you split an atom, fission, right? It doesn't just disappear or obliterate. It goes into a secondary, I think, cesium. So it kind of split in the middle, and then it becomes two different black holes, right? And all this matter or energy is released as heat. That's how I got that, I think. So that Zedo, that I think the calculation on the atom itself, whether it's plutonium or whatnot, right, can help find that c squared. That's what I'm thinking. The speed of it, how much energy it releases, and so on. It's a nightmare, right? I know, but I'm not your big time mathematician. Neither do I have time, Zedo, for that. So there's much to say, as a matter of fact. But I think that's I got these few things lately, and I thought I would convey those to you, along with something else, Zaid. Zaid, we can talk trash, Harai Alek and all that stuff all we want. But, Zaido, you're my son, and I keep thinking of you, and I love you. I can't eject you from my mind for some reason or another. Neither do I want to, let's put it this way. But something happened to me, and I know this for a fact, and I'm going to give it to you as an advice. I really hope you listen to me. Now, this advice, if you take it from me, if you take this advice from me, you will thank me in the future. If you don't, you will remember and you will regret it. And I'm sorry to hear. And I would be sorry, there and then. Continue what you're doing with the masters, but take a PhD in math, Zaid. Take a PhD in math. Take a PhD in math, Zaido. Don't cut yourself off and then go to become a lawyer. You can become a lawyer later, but do that PhD in math. By Allah, if you take this advice, you will thank me in the future. If you don't, you will remember it and you will regret not taking it. I know it's your life, but take that into consideration. And I don't know, 2 more years, for masters. 2 more years for PhD. Wallahi ya Zaid. Wallahi ya Zaid, you in the future you will thank me. And if you don't take it, you will come to regret it, and I will regret it, and I will be sad that you didn't. That's all I've got to say for today, and there's so much gibberish about that, but nonetheless, the flow of it, this guy Albert, and the man was, to me, the logic flows, right? You know how the logic flows is so congruent and so conforming to what he was thinking, right? That it's so simple. Sometimes the most simple theories or solutions or findings or discoveries is really what explains everything, right? It's really what revolutionized our knowledge and thinking and learning and so on. That's what he was thinking. I really, right now, I don't see anything else, really. It's that energy. He calls it energy. I call it non-matter, or a shade of existence, right? Not dimensional, right? And now I am more convinced that it's heat is what he's talking about. That moves into the black hole, and then it moves out as well. And your series and Fibonacci opposite each other. I don't know. But then again, I think you can get a lot of calculations, correct calculations, maybe near correct calculations of that C2 from. I don't think it's that simple, Zaido. I think it's a very large formula, to calculate the incoming and outgoing, right? The compression and the speeds and so on. But what you can get help, like I said, so the universe is not chaotic. So if you say, for example, simulate a galaxy fission, right? Bring this big gigantic thing and strike the galaxy in the middle. It's not just gonna vanish into space and dust and whatnot. No, it's not gonna happen like that. It's just like an atom. It's gonna split in two, right, and become two galaxies, right? And then those two galaxies, maybe they split. One galaxy. I said before, to one of your sisters or to you or somebody, that a galaxy gives birth to another galaxy. Now I am thinking maybe it's a fission, maybe it's like a division of a cell or a bacteria or something of the sort. Somehow there is what I term as limits of collapse. No system, Zaido, can go forever. It reaches a point where the logic within it and the physics in it doesn't allow it to go anymore, and it collapses, right? Either it collapses, and in my opinion, it somehow, a galaxy somehow just collapses in two, right? Like it splits. If unless there's a constant flow, then it stays as is, right? Constant, there's balance between incoming and outgoing. Incoming energy and outgoing matter, EM, right? So the E and the M, outward. So that's what I think, Zaid. I think that's what it is. This man was, and this is, I'm really hoping that you won't misunderstand why I am saying this. But really take my advice, Zaid. Take that PhD, Zaid, in math, finish it, and stay safe. And I love you, man. So take care of yourself, and if you ever here, I'll pay for some pizza. Have a nice day. Take care, son, and take my advice. At least promise me you think about it, Zaid. I love you so much. Bye now. خير عليك يا خير.